You know the cloud, right? We all use it. But have you ever stopped to think about where it actually is? It's not floating up in the sky. Nope. It's right here on Earth, inside massive, power-hungry data centers. But what if it could be up there? Today, we're diving into a really huge idea, the plan to move our entire digital and industrial worlds off our planet and into the cosmos. Okay, let's get into it.
In this quote from Elon Musk, it just nails the whole idea, doesn't it? It's a radical concept. It paints a picture of a future where Earth's precious resources are reserved for, living things, while all the heavy lifting of our civilization, the servers, the factories, the power plants, all that happens up there in the quiet cold of space.
So how do we get from here to there? Well, we're going to start with the crisis on Earth that's kind of forcing our hand. Then, we'll look up to the cosmic solution that's on the table. We'll check out the key players in this new space race, get real about the incredible challenges they're facing, and finally, see how they're actually starting to build this future step by step.
Okay, so first things first, we've got to understand the why. Our amazing digital world, especially with this explosion in AI, is creating a very real physical problem. The virtual is literally starting to eat the real world, and it's just not sustainable.
And look, this isn't an exaggeration. The AI models that are changing our lives are getting exponentially more powerful, which is great, but they're also getting exponentially more thirsty. And I mean thirsty for electricity and for water. We're talking about a level of demand that's really starting to stress our planet's limited resources.
And when you look at the numbers, it's just wild. The jump from 2020 to 2025 is already a big deal, but that projection for 2035, it's staggering. This trend line, it basically tells us that just continuing to build these massive server farms on Earth might not even be an option for much longer. The bottom line is, we need a new place to put them.
And that, right there, leads us to the cosmic solution. If Earth is a closed system, with only so much to go around, it makes sense that we're starting to look at the ultimate open system, space.
So this is the central question, really. The big one for our entire civilization right now. Where on Earth, or off it, can we possibly find what we need to power this next leap forward?
And the answer is so simple, so elegant. It's almost beautiful, really. We look up to the single greatest, most reliable power source in our entire solar system.
This is the big idea, right? We're calling it orbital infrastructure. And it's not just about launching another satellite. We are talking about a whole new industrial ecosystem in orbit. Just imagine data centers, solar power plants, and high-tech factories all networked together, floating above the Earth.
And this is where it gets really brilliant, because the physics just makes so much sense. First off, you've got infinite power. In orbit, the sun is always shining. Second, cooling is free. Data centers on Earth burn almost half their energy just to stay cool. In the vacuum of space, the cold does it for you. Third, a zero footprint on our planet. No land, no water, none of that. And finally, security. You're above earthquakes, hurricanes, and all the conflicts down here.
Okay, so this isn't just some cool idea on a whiteboard anymore. A new space race is kicking off right now. But this time, it's not about flags and footprints. It's about building the actual infrastructure for a brand new solar economy. So let's see who's playing.
And check it out, it's an explosion of different ideas. You've got companies like Starcloud planning a massive AI data center in orbit. You have Google, a giant, developing specialized AI chips that can survive the radiation up there. Then you have Varda Space doing something totally different, using microgravity to make better medicines. Or Besxar, trying to make perfect computer chips in a perfect vacuum. And of course, you've got countries like China getting in on it with huge plans for space-based solar power.
Now, you had early pioneers like Starcloud pushing this idea. But the moment everything changed, the moment this went from sci-fi to serious business was late 2025, when Google announced Project Suncatcher. When a titan like Google says they're going to launch prototype AI satellites by 2027, the whole world pays attention. It was this huge stamp of validation that, yep, the orbital economy is real and it's coming fast.
Okay, but let's pump the brakes for a second. Let's not get ahead of ourselves. Building an entire industrial base in orbit is, well, it might just be the hardest engineering project humanity has ever attempted. The road to the cosmos, as one engineer put it, is like climbing an Everest of challenges.
Let's start with the price of admission, because, wow. Right now, it costs around $1,500 to get just 1 kilogram. That's about the weight of a pineapple into orbit. So that server rack that you don't even think twice about on Earth, that could cost you $750,000 just for the shipping. The economics alone are a massive hurdle right out of the gate.
And then, when you get there, the environment is just brutal. Space is full of radiation that will literally fry normal electronics. The fix is something called radiation-hardened chips. But get this. You're going from a component that costs maybe $300 to one that costs $200,000. It's an absolutely insane price jump just to survive up there.
And the list just keeps going. Space debris? It's like a high-speed minefield up there, with tens of thousands of pieces of junk that can smash your satellite. Then there's latency. The speed of light isn't instant, so it's not great for things that need real-time data. And what happens when something breaks? You can't just send a repair person. And finally, the really tricky stuff. Whose laws even apply up there? It's a whole new legal frontier.
So yeah, the challenges are absolutely monumental, but they're not impossible. The same human cleverness that dreamed up this idea is already working on how to solve these problems. This is how the future is actually being built, one tough problem at a time.
So how do we climb that Everest? Well, there's a plan. Step 1 is the real game changer, fully reusable rockets, like Starship, which could slash launch costs. Step 2 is what Google's doing. Start small, launch prototypes, prove it can work. Step 3, you solve the repair problem by building smart robots that can do assembly and maintenance all by themselves. And Step 4 is the big one, getting everyone to agree on the rules of the road for space.
And you know, this quote just perfectly captures how huge this is. This isn't just about a new gadget or a new app. We are talking about a full-on new industrial revolution. We're moving beyond the resources of our own planet to tap into the fundamental power source of our entire solar system, the sun. Starlight. And this is the end game. Just picture it for a second. A future where humanity's second brain, our collective digital mind, is literally glowing in the night sky. Where our grandkids can look up and see the lights of our civilization, not just in cities on Earth, but shining between the stars. It's a pretty incredible thought.
So is this really the future? Are we headed for a world where our heavy industry moves off-planet, letting Earth rewild and heal? The obstacles are massive, for sure. But the promise of infinite energy and endless space is just so powerful. And maybe the biggest change is in how we think. For all of history, we've said the sky is the limit. But now we're starting to realize it's not the limit at all. It's the launch pad.